This lesson is find the determinant by row reduction to echelon form. So here I have a matrix 3 by 3 and I want to do row operations so that I can get the determinant. So here I have -1 and -2. I need this to be 0 and 0. So I will multiply +1, so opposite of -2, +2. Okay, so 1 times 1 is +1, subtract 1 gives me 0. 1 times 5 gives me 5, 5 subtract 4 gives me 1. 1 times -4 is -4, plus 5 gives me +1. Repeat that process for row 3. So 2 times 1 is 2, subtract 2 gives me 0. 2 times 5 gives me 10. 10 subtract 8 gives me 2. 2 times -4 is -8. -8 plus 7, -1. Next, we need this to be a 0. So again, we need this to be a 0. So opposite of 2 will be -2. So row 2 and then plus row 3. So -2 times 1 is -2 plus 2 gives me 0. -2 times 1 is -2. -2 plus -1 will be -3. And as you can see, the bottom left corner here, this is all 0. So now we just multiply the diagonal. So when I have 0 here, here, and here, we can stop solving for it. And then we just multiply the diagonal. Again, this right here is our upper triangle from the LU factorization lesson. Okay? So when I have 0 here, 0 here, 0 here, I can stop and then multiply the diagonal. 1 times 1 times -3 will give me -3. Now in this situations, I did not switch any rows, any columns, so there's no need for extra negative. Okay? Next example. Same thing, a 3 by 3. And I don't need this right here to be a 1 because we're looking for a determinant. Since we are looking for a determinant, this right here, this 3 right here, doesn't have to be a 1, okay? Now, it just happened that I'm going to use a scalar so that I can show you the rule of scalar, okay? So I'm gonna factor out this 3. Again, this right here doesn't have to be a 1, but for the purpose of using scalar, I'm gonna change it to a 1. Okay, so that I can bring this 3 with me all the way through to the end. If you remember the rule from finding the determinant by row operation, if I have a scalar, I have to bring it with me. Again, to find the determinant, this 3 doesn't have to be a 1. Okay, however, for this purpose, I'm going to use a scalar. Okay, so this example is just to show you the scalar. So I'm going to turn all of this 3 into 1 by factor out the 3. When I factor out this 3, this is my scalar. Okay, so divide by 3, divide by 3, divide by 3, or factor the 3. That gives me 1, 1, and -1. Okay, next, again, this is my scalar. 3 and 2 needs to be a 0, so opposite -3, opposite -2. So 3 times 1 is -3, plus 3 gives me 0. -3 times 1 is -3, plus 4, +1. -3 times -1 gives me +3. Subtract 4 gives me this -1. Do the same thing with row 3. -2 times 1 is -2, plus 2 gives me 0. -2 times 1 is -2, plus -3, -5. Negative 2 times negative 1 gives me positive 2. Subtract 5 gives me negative 3. Okay? Again, this is my scalar. Don't forget the scalar. Bring it along. Okay? Next, I need this negative 5 to be a 0. So opposite of negative 5 will be positive 5. So row 2, 5 times row 2 plus row 3. So 5 times 1 will be positive 5. Subtract 5 gives me this 0. 5 times negative 1 will be negative 5. Plus negative 3 will give me negative 8. And as you can see, here is my here's my left corner right here, where all this is 0. Then I can stop, multiply the diagonal, which gives me negative 8. Don't forget the scalar. Bring it along with you. So the determinant here is negative 24. One more time. When you find the determinant, this doesn't have to be a 1. Okay, this right here doesn't have to be a 1. The purpose of showing this example is taking a scalar. I factor out something, so therefore I have to bring it along with me. Okay, so that's one of the rules of finding the determinants. One more time. This 3 doesn't have to be a 1. It could be you can leave it alone. Okay. However, the purpose of this example is to show you the factor or the scalar. Okay, make sure you bring it along. If you factor something out, if you scalar something, make sure you bring it along. So don't forget that number. All right, so the first example was just regular row reductions. Okay, the second example, also row reduction with scalar or factor. Don't forget to bring along. And I did not switch row nor switch column, so there's no need for extra negative. And the last example, this is a 4x4 matrix, same procedure. So again, this right here doesn't have to be a 1. If it's already a 1, just leave it alone. Whatever that number is, leave it alone. Okay? If you can factor something out, then do it. If not, leave it alone. Okay? So 4x4, since this is a 0 already, we'll leave that alone. We just need this 2, this negative 3 to be 0, 0. So opposite, which is negative 2, opposite, positive 3. So negative 2 times 1 is negative 2, plus 2 gives me this 0. Negative 2 times 3 is negative 6, plus 7 gives me this 1. Negative 2 times 2 gives me negative 4, plus 6 gives me this 2. Negative 2 times negative 4 gives me positive 8. 8 subtract 3 gives me this 5. Last row, 3 times 1 is 3, subtract 3 gives me 0. 3 times 3 is 9, 9 subtract 10, negative 1. 3 times 2 gives me 6, 6 subtract 7 gives me this negative 1. 3 times negative 4, negative 12, plus 2 gives me this negative 10. Okay? Next, I want this 1 and this negative 1 to be 0, 0. I want this 1, this negative 1 to be 0, 0. Okay? So opposite of 1, negative 1. Opposite of negative 1, positive 1, which I wrote here. So row 2 to row 3, row 2 to row 4. So negative 1 times 1 is negative 1. Subtract 1 gives me this 0. Negative 1 times 2 gives me negative 2. Subtract 2 gives me this 0. Negative 1 times negative 5 gives me positive 5. 5 plus 5 gives me this 10. Last row, 1 times 1 gives me 1. Subtract 1 gives me this 0. 1 times 2 gives me 2. 2 subtract 1 gives me this 1. 1 times negative 5 will be negative 5. Negative 5 plus negative 10 gives me negative 15. Okay, next If you notice something, this is a 0 and this is a 1. We need something here, okay? We cannot have it a 0. Again, this is a 0. We need other number besides 0. So what we're going to do is we're going to switch the rows. Switch the rows. So 4 go up, 3 go down, which I have right here. So row 1, row 2 stay. Row 4 go up to 3. Row 3 go down to 4. Again, I want to switch this 2 rows because this right here, this spot cannot be a 0. It could be any number but not 0. Okay, once I switch the rows, don't forget the negative. Once I switch the row, don't forget the negative. I have to put that negative in. And as you can see, the bottom left corner right here, the bottom left triangle right here, all 0, so we can stop. Now just multiply the diagonal. 1 times 1 times 1 times 10, which is positive 10. But I have a negative here, so now the determinant is negative 10. Okay, so in this lesson, I want to show regular row reductions with no factor, no switching rows nor columns. This is just regular row reduction. This second example, row reduction with factor and scalar. The last example is row reduction with switching the rows or columns. So be very careful from finding the determinant using row reductions. The first rule, it does not change the results, the answer. However, if I have a factor or scalar, make sure bring it along. If I switch any rows, or columns, make sure I put an extra negative in. Okay, so this lesson is just reinforcing the rules of finding the determinant when I use row reductions. Okay, so one more time, this is just a reinforcement lesson when you find the determinant using row reductions. If you're not changing anything, so it's just the same answer. However, if I have a factor or a scalar, make sure I bring it along. If I have switched the rows or columns, make sure you put the negative in, extra negative in.